All right, one more of our ghost tale science stories. So I want to just talk really quick about the indirect and direct sunlight. So our sun, right, is at this 90-degree angle here. So you can see right here is getting that direct sunlight. I can still see light happening. Oh, can I stick this in here? Is this magically going to work? There we go. Okay, there we go. Now I can talk with my hands that I like to do. Okay, so sun's over here, right? This is getting the direct sunlight. But I can still see that there's light up here. It's just not as intense as this bright spot right here because it's having to hit the surface and then spread. So here's our direct light. So that equator line right in the middle is always going to be the hottest because it's getting the most direct light, where this light's going to have to spread out. So then in the summer, when it's more pointed toward it, it will get a little bit more, but in the winter, when it goes the other way, you can see it gets less. So summer gets more direct light, but in the winter, it's pointed away from the sun, it's going more into the shadow, and there's getting more light lower below the equator. But no matter what, that equator is always in that direct line of the sun, no matter which way we go, winter or summer, that equator is always in that line, direct, and then indirect has to go and spread out. So hopefully that helps you understand the difference between direct and indirect sunlight. Okay guys, it's like 6 in the morning and I'm sorry, these are getting really weird. Okay, bye. So the sun gives out the same amount of energy every day, giving the same amount, depending on if the nearest pole is pointed toward the sun or away from the sun. It can change the angle of the light. So, right, if it's coming straight at it, that's going to be 90 degrees. And we can see different parts of it, though, right, are going to get more in the middle, and then it has to spread out. So in the summer, the light is more focused, so we get more direct sunlight because we're tipped more toward it. It's coming more at us. Where in the winter, we're tipped back and it has to spread out. It hits us and then it has to spread over this whole area. So this is direct sunlight, right? It's that flat on. But here, towards the poles, it hits and then it has to spread to cover that area. All right, this just hits it and it covers it, where this hits and it more has to spread, and we're going to call that indirect sunlight. So down here on this flashlight area, it's kind of the same example here. So, right, if it's straight on, that is going to be our summer flashlight, right? It's going to have that 90-degree angle, right? You can see it's really intense, focused right there. And then this is our winter flashlight because it hits and then it has to spread out. So it's getting the same amount of energy, but that one's having to spread out because we're tipped away. So it hits and then it has to spread to cover that area. So in the summer, right, we get that straight on light that we call direct light. And in the winter, it has to spread out, so we get that indirect light. Okay, so go ahead and finish those sections. So our biggest takeaway, seasons, we've got to tilt and we've got to revolve. And that is giving us that unequal heating. We've got more direct light at the equator, and depending on whether the pole is tipped toward or away from the sun, we've got more direct or indirect sunlight causing those seasons. So tilt and revolutions make the seasons because of the unequal heating of direct and indirect sunlight on our Earth.